let's start immediately with our first pitch. So it's Nerian Vision. Konstantin, the floor is yours for 8 minutes.
Great. Thank you for the introduction. So before I start, I just want to say a few words about Nerian, about who we are, what we do. Nerian started right here in Stuttgart in 2015, so it's already been 6 years. But we're still a very small startup, and we are specialized in real-time 3D camera systems. And now here at the Vision trade show, we're now presenting actually our third generation of high-speed 3D camera systems. And though we're still very small and young company, we already have some prestigious customers from around the globe. Now, high-speed 3D sensing is what we do. And the problem with most existing 3D sensors is that they can either measure with a high resolution or at a high speed, but typically not both. And this, for many applications, this is a problem because they need high resolution and high speed. And so typically these are systems that have to quickly react to their environment. And so some prime examples are autonomous vehicles and advanced driver assistance systems. So they have to react quickly if they sense any imminent danger. And also they need the resolution to recognize this danger early on. But in the same sense, many autonomous systems require this sensing capability. So I just listed a few examples here. So for example, autonomous mobile robots, like they're used in the logistics applications, autonomous construction machines, or agricultural robots. All of the applications, you are in a dynamic environment to which you need to react. Now, with our latest sensor system, which is here, which is the Scarlet 3D camera, we can do that. We can do high resolution and high speed at the same time. So with this camera system, we're able to measure 70 million 3D points per second, and the camera can do 5 megapixels image resolution and 120 frames per second. Not at the same time, though, but you have a choice there between how much resolution and how much frame rate you want, so it's very configurable in that sense. And yes, it comes with this very ruggedized form factor with IP67 protection, integrated IMU, and has a 10 gigabit Ethernet interface, so we can actually move the data out of the system fast enough. The measurement principle that we use with Scarlet is stereo vision, so practically mimicking how we humans are able to perceive depth. And this is fundamentally different from how most existing 3D sensors work on the market, in that we don't need to project any light for doing measurements. And this has the great benefit that you can use a stereo camera outdoors during bright daylight, and you don't have any problems with the sunlight overcasting the light that's being emitted. Also, you can do measurements from long measurement distances without having any range problems there. But the major, this stereo vision still comes with a downside, and that is that you need a lot of computation for doing the required image processing. And we solved this problem for Scarlet by doing hardware-accelerated image processing. So we integrated a very powerful FPGA into the camera, and on this FPGA, we are running all image processing in hardware. So we developed a highly parallelized image processing pipeline, and through this we get a very high processing speed, but also an extremely low latency. So a lot lower than could be done with any GPU-based system. And this also means, because all of this processing is done in the camera, there's no processing to be done on the host PC, or so we don't waste any processing resources there. Now I just want to go through some videos of what the system can actually do. So this is some example video that was taken for an automotive application. So these are all recordings from done with the vehicle. And what we can see here is we get this very dense measurement with Scarlet. And also at the same time, we are able to get measurements both from close objects, but also for very distant objects. So we have a very, very far visibility and get this very rich scene information. Then, yeah, so if we look at the next video, so this is just a frame. This is a frame from the video we saw earlier, a still frame, but now visualized as a 3D point cloud, just to show that actually what we're getting it's a full 3D information. So where in the previous video we had this color-coded depth map, here we now have a 3D point for every single point, but it's the same measurement information. Right. So where are our cameras used today? So Scarlet is a brand new product by us, but it's the predecessors of Scarlet. They've been used by different customers in industry and academia. Unfortunately, it's always a bit difficult for us to talk about industry customers, but luckily academia is a lot more open in that sense. So I'm aware of now, I think now 16 published research papers where our cameras were used in some applications, and just to show some example here below, this were two teams from the formerly a student competition. So this is an academic competition to build autonomous race vehicles, and we had I think actually 3 different teams that used our cameras so far for this competition. Right. So I've talked a lot about these mobile robotics applications, but we can also use our cameras for the more classical machine vision tasks, such as bin picking or automated inspection applications. When you do such applications, what we typically would use also a pattern projector to project more structure onto the scene and increase the measurement quality. And with such a system, we could also measure surfaces with very uniform color without any visible surface variation, which is typically a problem for stereo cameras. So this example here, this was a recording for a bin picking test, and these are actually pictures of different types of plastic tubings and fittings. So in summary, I think that stereo vision is a very promising technology, and with our Scarlet camera, we're actually able to do stereo vision at a high speed and a high resolution at the same time. And I see it's particularly suitable for difficult use cases, like I already said, outdoor long-range applications, but can also be used for many other things. And because the camera is very configurable, it can be very well adjusted to all sorts of applications. So with that, I'm at the end of my talk, and I actually invite everyone to just come by at our booth. We have 3 live demos of our camera systems there, so please come by and check them out in person. Right. Thank you.
Thank you, Konstantin. Jury members, do you have a question to Konstantin?
Just one question. If you use it for autonomous cars, driverless cars at night, and there's not much light, you'd have to have a light source. I mean,
yes,
the LiDAR would have that included. How does that work then?
Yes, we did before for one company. We did test recordings for night driving just with the headlights of the car, and that worked surprisingly good to my experience. But of course, you're limited there to what area can the headlights illuminate. One option is to actually use infrared lights, and I've seen this in use in some vehicles, that they have strong infrared light sources to illuminate a larger region, but without blinding other drivers. But yes, in the end, you need to have lighting to do measurements.
I mean, you're mentioning a lot of use cases from driverless cars to mobile robots to bin picking and so on. Are you really going for the autonomous self-driverless car, or? We
have some customers from that market. We're not developing applications ourselves. So I see us as the 3D camera provider, and we provide the 3D information for the customers to implement their solutions.
Thank you, Konstantin.